Hello, in this video we'll be talking about stepper motors, and this is an updated video. If you're watching this for the first time, so just ignore the first minute, what I'm going to say, and if not, so I have made some changes. So I have added something on the steps per revolution. I've updated the presentation, so I will be uploading that as well. And likewise, I've made some changes to the assignment question because if you think about stepper motors, so stepper motors are like, say, it's a specialty motor which is known for making precise movements. So it would be ideal to control the position rather than time. So time is not a critical factor here. So instead of having time as the configuration or like a required parameter, so I've changed that to revolutions. So you will have to make revolutions accordingly. So here, let's get started. I've made some changes, so this is going to be a new video, but I'll be explaining a little bit more about stepper motor in this video. So stepper motors are, again, as I told earlier, so it is a motor, it is a specialty motor like that is used to make precise movements. So in general, motors will convert electrical energy into torque, so that torque can be used for doing some useful work. But here in this motor, like we are using that torque to do something very specific, like moving something to a particular position. For example, printers. Let's say if you don't make precise movements, so you might be printing the words over and over, or like you can have like too much gap between letters or characters, so things like that would be a problem. So that's where like stepper motor comes in handy and helps you to make precise movements and then like get the results you need. So here, this is kind of the setup which is exactly present in the kit, the motor that is present in your kit. So here you will have a cogged wheel which will have 32 teeth, and then apart from that you will also have a stator. The stator has 4 poles, and those 4 poles are like connected, or like that's where like we give the pulse, and then that will turn the motors in steps. So what happens is, like say the stator and the rotor, like both of them will have teeth, so that when you apply, so you know what is the when we talked about charge, we were talking about like charges repel each other and like charges attract each other, right? So here again, like the stator is made up of an electromagnet. So when you apply electric current, it turns into a magnet. Likewise, the core or like the rotor is a magnet as well. So when you have like poles, they will repel, and unlike poles, they will attract. So that is what is happening in this teeth actually. So when you have let's say when this is excited, so all these teeth will be a magnet, and then it will try to attract. If it was like misaligned, like it will try to align the sharp pointy edges to the pointy edges of the stator. So that's how it makes a step. So to for this motor to complete like 1 revolution, so we'll have to apply like 32 pulses. So every time like you make a or like if you every time you provide a voltage to this coil, the current runs through it, like, and when the current runs through this stator coil, this becomes a magnet, and then it kind of attracts and it makes 1 step. Likewise, you do it in a sequence to kind of rotate it in steps. So this motor like requires 32 steps to complete 1 revolution, right? Like this is the important information which I did not give in the previous video. So here, so that is the important thing. And by controlling the sequence of the pulse, so instead of going 1, 2, 3, 4, if we go in the reverse direction, 1, 4, 3, 2, then you will be spinning in the counterclockwise direction. So that is one thing. And you can also increase the speed by increasing the frequency of the pulse. So how often you apply the pulses. So you can increase the speed. Likewise, and again, there is a limitation though, like you can't go beyond a particular speed, then you will see just the motor vibrating and like it will not respond to the pulses. So you'll have to be like a little careful on that. Like we'll also talk about the speed later when we are coding the motor. Likewise, the number of pulses will determine the step size. So that are some important things about the stepper motor, and very specifically this stepper motor has a gear, and the gear ratio is 63.68. You can approximate it to 64. So one for if it makes one revolution, so for sorry, like maybe let me explain it in this way. For this motor to spin or like say to complete one revolution, the motor inside, again, this is the motor, like which is inside, will spin, it'll need like 32 steps to complete one revolution, right? But here this would need 64 times 32, like say that many times of revolutions to complete, like revolutions of the motor to complete one revolution in the output shaft. So there's difference. So that's what the gears does actually. So if you make with the gear, if you make one revolution, if you make 64 revolutions, that will be converted into one revolution in the output shaft. So that is kind of the theory behind this. So that's what gears do, mechanical gears. And here in the stepper motor, as we said, without the gear, like it'll make 32 revolutions, it will need like 32 steps to complete one revolution. But with this gear, so you need to multiply that by 64, you need 2048, like 2048 steps. If you exactly multiply without rounding, then like you will get like 2038. So that many steps to complete one revolution. So here, this is the driver we will be using because we are drawing power from the Arduino. So if you connect the Arduino directly to the motor, like say it might draw too much power, and like say that might draw too much power, and like maybe the Arduino might not be able to provide like that much power to the motor. So we will be using the output of Arduino to control as control inputs, and then we'll be driving the Darlington pairs. These are just transistors, so you will have 7 inputs, 7 outputs, and then you have 2 ground or like say positive and negative pin. Ground and VCC pin, and this has 7, but like we'll be just using 4, and we'll connect the motor here, and these are the indicators, LED indicators indicating which pulse is on, or like which pin is on and which coil is on. And that's what's indicated here. But usually you will see like you will not see that those pulses, so because your number of pulses, like the frequency is going to be really high. Here is the circuit, and we are not this time, like I'm not going to be using a parallel connector. I will just like try to use and draw power from the Arduino. So here is the code. So here, steps per revolution is the number we saw. So 63 point something times 32, and here is the sequence of my input. And then here are 2 things, like set speed is the speed at which I'm rotating. So I will be rotating again, like I would suggest a number between 1 and 15. Anything more than that, like the motors will vibrate, but like it will not rotate. So the number of pulses will be too much. So the motor will become unresponsive. So I would suggest a speed between 1 and 15. And here again, like we are making steps. So when we say mystepper.step, so we are saying make this many steps. So when I say make this many steps, so to complete one revolution, we have to go 2038 steps. So once, as soon as it goes 2038 steps, it will complete one revolution. So when I run this code, you will see one revolution is being complete. So if you wanted to do 2 revolutions, so you will have to run 2 times 238 steps, so it will do 2 revolutions. So that's how we are going to control this motor. So let's see the assignment question as well. So here again I have changed. So clockwise you will have to do 2 revolutions and then stop for 2 seconds, and then counterclockwise 1. My bad, just give me a second. And counterclockwise, you will do 3 revolutions, stop for a second, clockwise 1 revolution. So this is what you will do. Let me go into the setup here. And meanwhile, I will also bring the Arduino sketch. So here is my sketch, and then we will just see this maybe. Shall I? Maybe I will run it again. You will have access to this. I will update the program that is present in Brightspace right now. I will just upload this right now and then do the things towards the end. Okay. So I'm running. So right now you see the motor moving. Let me make this bigger. Okay. So if you see where it starts and stops, I'm just gonna, okay, so it starts here. It started here. So it should finish here to complete 1 revolution. Okay, oh, for some reason I'm doing half revolution, so just give me a second. So here, if you see, I was playing with it, so I'm doing half revolution here. So I don't want half revolution, I want like full revolution. So let me clear that and upload it. So let's see what happens now. So now it should complete like 1 full revolution. So where did it, like, where are you going to stop? Yeah, so it stopped here. So it has to finish 1 revolution, which means it has to stop right here. So that is 1 revolution. Maybe I spend it, maybe. Yeah, but like say again, like now you know the concept actually. So this is what you will have to do. So let's say if I wanted to make, let's do that. Let me do 2 revolutions every time. So let me do that. I will just like multiply that to, maybe for this I will use a parenthesis. Let me run that now and see. Okay, done uploading. So let's see whether it does 2 revolutions. So it is doing. Okay. So that is 1 revolution. And it's not quite there though. Maybe that might be to do with the approximation. It's a little. Wait a minute. So here 1028. Like let's try 2038. Let's try 2048 maybe. So let's see whether that makes any difference. So here, instead of having, I will do that. So just the approximation might have made the difference. So let's get started. Let it finish the first 2 revolutions. Okay, it has finished there, right there. So let's see whether it finishes 2 revolutions. No, maybe it is not clear. Well, that is 1. Come on, come on, come on. And that's 2. So that is 2 revolutions. So you can control the revolutions by adjusting the step size. So that is the assignment problem. So you can do that, and I hope now it's a little bit more clear on how to approach this problem. And yeah, if you have any questions, please let me know. I'll be more than happy to give you more information if required. And see you in the next video if you haven't watched the entire Module 3 videos. See you.